measures of central tendency and dispersion. So here we're going to understand the central tendency. That means the entire data, usually when we are analyzing data in statistics, we like to know where the center of the data is, which is, there are three ways to measure the center. So measures of central tendency means measure of the center, and there are three of them. And one of them is the mean. Mean is same as average, which is also same as expected value. Same thing we discussed in the last class, expected value. We learned in the last class that expected value or mean is equal to adding up the frequencies times values. Each value has a frequency. You multiply frequencies and the values, add them up, and divide by the total frequency. Total frequency is the same as total count. So, and statistics work will describe the formula for mean as this, either this or this. They're both the same. Numerator is products of summation of the product of frequencies and the values. And denominator is sum of the frequencies. So we already used it when we found expected value, but when we found expected value, we also wrote this as another one, which is, I'm going to write on the board instead. It is also equal to sigma pi xi, the values times probabilities, that same thing. So if I need to find the mean, which is same as expected value, if they give you frequency distribution, then you apply one of these formulas. If they give you probability distribution, then you have to apply the formula here on the board. It's all the same thing, same as expected value. So let's do this, these simple examples to understand the idea. This is the data given to you, and it says find, make them, put them on a frequency table first, and then use it to find the mean. All right, so the values are 60. The 60 has a frequency of, what is the frequency of 60? Anybody?
2.
2. There are two 60s in there. And 72 is the next one. You don't really have to write them in order, increasing or decreasing order, but if you write them in order, you won't miss anything. For that reason, I prefer to do that. Okay, 72 has frequency of
2.
2. And the next data is
85.
85. 85 has what frequency?
3.
3. Okay, and next one is 90. And what's the frequency for that?
1.
1. Okay. And then 98 is there with what frequency?
2.
2. Okay, so there are two 60s basically. So we write the product of FIXI. I'm not writing the title there, but FIXI.
120.
120 here, right? 120 and 144. 144. 255. 90 and 16, 196. Okay, now you add these up. Now adding these up is same as adding these up, clearly, right? We just wrote them each value, and then we wrote the number of times they repeat. And so 2 times 160 is 120, which is same as the 60 here plus the 60. So you're just doing it in a different way. That's all. So if I add these up, that's same as the sum of all the data. And so let's do that. What do we get? 196. I'm using my calculator now to add them. Plus 90 plus 255 plus 144 plus 120. 805. So equal to the mean equal to 805 divided by what? The total frequencies, which is 7, 8, 10. There are 10 data. So we can either count the data or add up the frequencies. It's the same. So that's equal to 80.5. So that's your mean. It's also the expected value. All right, so here data and the frequencies are given. And so you put Fi(xi) in the next column, add them up, and divide by the sum of frequencies. We don't need to go over that one. Now the question is, if the data is already grouped into class intervals, then how do we find the mean? So here the data is grouped into frequency table, not class intervals. So these calculations are perfectly accurate. There is nothing wrong here. These are accurate calculations. But what if the data is already grouped? Remember, we discussed in the last class that if the data is a very long list, then it's not manageable. It's not something we can work with easily. So we bring it down by grouping them into intervals. So sometimes the data, let's say you're a statistician, you're going to analyze something, and the data is given to you in grouped form. It's not available in the raw form. Original data is not available. So they give you this. These are in these intervals, we have these frequencies, which means we have so many data in each frequency. That's all you know. You don't know exact data. So if you don't know the exact data, how do you find the mean? We can only find a good estimate of it. That's all we can do. And that's all we need in statistical analysis, usually, a good estimate. So I'm going to explain how to find that estimate. We are only finding the average. So average can be average of averages. Mathematically, it is accurate to find average of few. See, if I have 20 numbers, let's say, first I need to explain the mathematical fact. If I have 20 numbers available, and if I add up first 5 and divide by 5, and then add up next 5 and divide by 5, that's average of the next 5. This is average of the first 5. And if I do that, and then average the next 10, divide by 10, now we have 3 numbers. If I average these 3 numbers, I will get the same average as the original 20 numbers. Okay, it's mathematically correct. But normally we have no reason to do that. But here, when the data is grouped into intervals, we're going to have to use that kind of idea. This interval has 4 data in it. That's what it means. The 4 data can be spread within this. One of them could be 51, the other one can be 54. We don't know what data they are, but it is reasonable to assume that the average of all those data is same as middle point, because they are usually spread apart in the interval. Means if you average them, normally it will be the middle number. So we take the middle number, we call it M, and that will be our average for this interval. So average of the data, all of the 4 data that are in this interval can be assumed to be 55. See, this interval is going from, not 55, sorry. This interval goes from 50 to 55. Remember, you write 54.9 to mean everything below 55, right? So the interval width is actually 50 to 55. So the width is 5. So to find the halfway point, you need to take half of the width, which is 2.5, and add it to the left end point. That'll be the best way. So let me go to the board here. There are 2 ways to find the midpoint. Finding midpoint is necessary in not only this problem, in many problems coming up later. So two ways to find midpoint. One is take length of the interval and divide by 2 and add it to each beginning of the interval, each beginning. So 50 plus 2.5, 52.5 is the middle. The next interval has 55 as the beginning. So 55 plus 2.5, 57.5 is the middle, and so on. So add length over 2 to the left endpoint. That's one way. Second method is just to average the left endpoint and the right endpoint, 50 and 55, add them up, divide by 2. That's equal to 105 over 2, same as 52.5. So either average the two endpoints, but you have to remember that 54.9 means 55 is the left endpoint, just the 55 is not counted in here. That's all it means. Very often students make the mistake of averaging the actual numbers here, which is wrong. 50 and 55 should be averaged. Okay, so either way, the midpoint here is 52.5. So I write that there, 52.5. And the next one, anybody tell me midpoint here is? What's the midpoint for the interval 55 to 60?
57.5
plus, yeah, 55 plus 60 divided by 2.
Right. Either that or add 2.5 to the 55. That gives you 57.5.
Yeah.
And the next one is? Sixty plus?
62.5.
Yeah, 62.5. 60 plus 2.5. Next one is 67.5. Okay, so what we are doing is we are finding the average of all the data in this interval and assuming that that average is 52.5. And the average of all the data here is 57.5. That's a reasonable assumption because that's about how it happens. So now we can assume that 52.5 occurs 4 times. The same number 52.5 occurs 4 times. And 57.5 occurs 6 times. So now our data is very similar to the data here in the previous list. This. Each data and the frequency is available and work with them in the same way we worked with them. The only difference is your data now is the midpoint, which is reasonable. We are using the average of all the data within each interval, and we are now going to average all of those to get the average, which is mathematically correct, as I explained on the board. So what you need to do next is multiply FIMI. So FIMI is what we need. And so 52.5 times 4, 52.5 times 4 is, hold on, 50.
210.
Yeah, sorry, my calculator is giving me some problem here. Okay, 4. So 210 and the same way, you just write them all these products here, FIMI, and then write them up, put it at the bottom. And then sum of the frequency is 1018. So to take the 18, you divide this sum by 18, just like we did before. That's all it is. So whenever you have the data already grouped into intervals, you have to find the midpoint of the interval and use them as the actual data. And by doing that, the expected value or the mean you find is going to be very close to the accurate value. It's not going to be far off. And that's a reasonable approximation. And that's all you can do. When you have only data grouped into intervals already, then this is the best you can get. So what do we do here? Just this exercise, this is exercise for you. So
Professor?
yeah,
So for the last problem, you said that if we were to divide 881 and 18, what would that give us the answer to?
the mean, we're finding mean.
Just the total mean?
Yeah,
Okay, thank you.
all the data. Find the mean of the group data. So that's what we are finding. So to find mean, which is average, you can take averages and average them. That's the principle. It's a mathematically correct principle. That's what we are doing. These numbers represents average of the data that are within each interval. And those averages can be averaged now. So that's what we're doing to find the mean. So here in this exercise, to find the mean, I need to do what next? In the next column, what do I need to find?
The average.
Right, or middle point, right? The middle point will represent the average.
Yeah.
Okay, so middle point will represent the average. So what would be the number that goes here?
11.5.
11.5, right, very good. For the others who, if you don't see it, let me explain. The width of the interval is 3. It goes from 10 to 13. So width is 3 and half of that is 1.5. So I need to add that to the left-hand point, and that's 11.5. Similarly, add the 1.5 to 13 and 14.5 and 17.5, 20.5. Okay, so those are your data now with these frequencies. And so find Fi, Mi in the next column, add them up and divide by the total frequency. That's all you need to do. So it's simply arithmetic, so I'm skipping that. So the mean is one of the measure of the center. The mean usually comes to the center, the same as the center of the entire data. But there are other measures of the center also. There are median and mode. So let's understand those. The median of the data is the middle of the data after you arrange them in some order. You can arrange them in increasing order or decreasing order, and then find the middle, and that is called median. It is a measure of the mean, a measure of the middle. So there are three measures of the middle. The first one was mean, second one is median. Median is the middle point itself after you arrange them in a increasing order. Let's also understand the mode. Mode is the data with the highest frequency, the data that occurs most frequently is called the mode. Okay, so let's do an example. This is the data given to you. We're using simple example to illustrate. First of all, can you tell me what the mode is?
7.
7 is the mode. 7 has a frequency of 3. There are 3 7s. So therefore, 7 is your mode. There may be sometimes more than one mode. And for example, I have 7, and then let's say I also have 9 repeating 3 times. Now there are 2 data with the same frequency. So in this case, the modes are 7 and 9. So it is okay to have 2 modes. What if there is no, sorry, that's for the mean. That's for the median. So let's go to the median. Now we have these numbers arranged. Let me eliminate the 9s. These numbers are already arranged. So to find the median, you need to locate the middle number. So middle number means you had to calculate how many numbers are there, and then So how many are there? Count of data is 2, 4, 6, 8, 9 data are there. When there are 9 data, there's going to be one middle, odd number of data, right? There will be one middle and there will be 4 data on either side. So when you have 9, there will be 4 data on the left of middle number, 4 data on the right of middle number. The middle number is going to be the 9th one. So only when you have odd number of data, there's one middle. And here we have odd number of data. And so we can okay, so there are odd number of data, so therefore there's one mean. And how do we locate that? What you do is take the count of data, which is 9, add 1. I mean, this is small collection of data, so you can see that the 6 is the middle one. There's 4 data on the left of, on the right of 6, 4 data on the left of 6. But the list can be very long. So if the list is long, how do you identify where the middle is? You take the count of the data, which is 9 in this case, and add 1. When it is odd number, you add 1 and divide by 2. That'll tell you where the center is, where the median is. 10 over 2, 5. That means 5th number is the median. So you go to the 5th number, count from the left and go to the 5th number, that's 6. So that is the median. You cannot just visualize when the list is long. Now you can visualize here, but not always. So that's why the formula has to be applied. The number of data plus 1 divided by 2. It's put in, it's in the box here. That tells you the location of the middle. That's when it's odd number of data. If you have even number of data, then there will be 2 middles. So let's look at this example. I have 4, 6, 8, 10 data here. When there are 10 data, there are 2 numbers in the middle, 4 and 6 actually. Right? On the left of 4 and 6, there are 4 data. On the right also, there are 4 data. So 2 middles. So how do you locate the middle when you have even number of data? So on this formula here applies odd. When you have odd number of data, the formula is this. When you have even number of data, you just take the count itself and divide by 2. The count already is even number, so it's divisible by 2. If you divide by 2, that'll give you one of the middle, and the next middle is the very next one. So in this case, I have 10 data. So 10 over 2 is 5, which means 5th data is one of the middle, and the other one is 6th data, which happens to be 6. So to locate the middle, you divide the count by 2. If the count is odd, you add 1 to it and divide. That'll give you the location of the middle. If the count is even, then divide it by 2. That'll give you one of the middle. You go to the next one, and you have 2 middles. And when you have 2 middle, you're supposed to average them. So if there are, the median will be only one number. If there are odd number of data, that median will be one number. It's in the middle. There'll be one middle. If there are even number of data, there will be 2 middles, and you need to average them to get the median. Average of the 2 middle will be the median. So when it comes to median, there's only one median, and you have to find that. When it comes to mode, there can be more than one mode. Okay, so here is the exercise. The data is given to you. I need you to find the median and mode.
The median is 6.5 and the mode is 5.8.
Okay, mode is, I think you switched the names.
Yeah, the mode is 6.5.
5.
Yeah, and the median is 5.8.
Right, that's correct. Okay, everybody see that? The 5.8 is the middle, and if you cannot locate it, you can count entire data. there are 3, 6, 9, 11 data there. So there will be one median. And so you divide 11 plus 1 over 2, that's 6. So sixth element is the median. So that's 5.8. Now the mode, 6.5 is the one that has highest frequency. Now, remember, it's the data that has highest frequency, that's your mode. The mode, the frequency of this is 3, so sometimes I get the answer as 3. Nope, that's the wrong answer. The data that has the frequency, the highest frequency, which is 6.5, that's your mode. All right, so this data, this list has even number of data. Okay, what's the mode? Let's begin with the mode first.
There are two modes, 4.3 and 6.5.
Right, very good. Two modes are there, 4.3 and 6.5. See, both of them have frequency 3, 4.3 and 6.5. So there are two modes. Okay, now the median.
We have to add 5.4 and 5.8 and then divide them by 2.
Right, average 5.4 and 5.8. So that's 11.2, 10.8, 11.2. So 11.2 divided by 2 is 5.6. So that's your median. And the mode, there are two modes. All right, so I hope everybody got that. Now, these are very simple ideas, nothing complicated. So I'm sure all of you are able to understand that. Now, mean and mode from the frequency table. So sometimes the data is going to be already organized in frequency table form. And so you don't have the raw data. You have to work with this table.
I'm sorry, Professor, but for the last exercise, for exercise 7, when
Yeah.
we found the median, how did we find it as 5.8? Because I'm thinking we just looked at the numbers and selected 5.8, or did we calculate?
We calculated. You can actually, in a short list like this, you can figure out by looking. But you need to learn to apply the formula because the list can be long. So you count the data, and there are how many? 4, 6, 8, 11 data there. Okay, so odd number of data, that means there is one median, right? If you have odd number of data. So you need to locate the median. So if you have odd number of data, remember I said you add 1 and divide by 2. So that's 12 over 2 equal to 6. That is the location of the middle. Okay, so sixth number in the list is your median. So
Okay, that's what I needed. Thank you.
so you count from the beginning, and the sixth number is right there. Okay. But when it comes to the odd number of data, there will be two middles. To find both of them, you just divide the count by 2, and that is your first middle, and the next one is the second middle. Okay, and we found two of them, 5.4 and 5.8. All right, let's go back to the mean and median, mean and mode from frequency table. Now, mean is easy to find from this because it means this data 2.5 is there 3 times. Data 3 is there 4 times. That's what this means. So to find the mean, we just have to make another column for the FIXI, right? So you make another column for the FIXI. Well, I'm going to have to copy and paste this. Okay, so, all right, gave me a weird looking table. Okay, we have xi and fi, so we need to make another column for fi xi. So you make a third column. Fi xi, and so 3 times 2.5, 7.5, 4 times 3, 12, 3 times 4.5, 12, 13.5, 6 times 5.5, 30 plus 33, 12. And so add them up. Let me see. And then you divide by the total frequency, and total frequency is 10, 16, 18. So you divide 78 by 18, that gives you the mean. So mean is easy. We already learned before. Fi xi can be calculated in another column, and then you divide by the 2. So because 2.5 is there 3 times, so 3 times 2.5 is the total of those. 4.3, 4 times 3 is the total of all the 3s, and so on. And then you are adding them, dividing by the total count. Now that's how you find the mean if they ask for that. But this one says median and mode. Okay, mode is fairly straightforward because you can see each number and the frequency on the right side. Okay, so you're looking for the data with the largest frequency. So which data is the mode?
5.5.
5.5. So mode is 5.5. Okay, now we need to find the median. Median is the middle number, right? After you put them in order. Now these numbers are already in order. The only thing is the frequencies are there. So if you really want to write them, then write them in order. You're going to have to write, I'm writing on the board, 2.5, comma 2.5, comma 2.5, because there are 3 of them, right? And after that, it's 3, comma 3, comma 3, comma 3, and the list goes on. And then you had to locate the middle. That's kind of awkward, even though that is correct. This is short list, but if it is actual problem, in real life problem, it'll be, the frequencies are very large normally, and so you have to make a long list. That's unnecessary. So you need to learn to figure out the median just from this list without doing any other work. So let me show you how to do that. There are how many data? We can find that by adding these numbers. That's 11, 15, 18 data are there. So total count of data is 18. And that means the middle is going to be, there are how many middle, 1 or 2?
1.
There are
Actually, there are
2,
2,
right?
yeah, because it's even number.
It's an even number. 18 is even number. That means 2 middles are there. They will be which one? Which are the locations? What are the locations of the middle?
9 and 10.
9 and 10. You just divide the 18. When the count of the data is even, you just divide that by 2 for the first middle, and the very next one is the second middle. So 9th and 10th are the middle ones. Everybody's with me so far? All right. So 9th, we need to locate the 9th element in this list. All right, so here's how you do that. When I pass the data 2.5, I'm passing 3 data. And when I pass 3, I'm counting from the beginning. And when I pass all of the 2.5s, 3 data I have passed. I'm looking for the 9th. When I pass the next data 3, I pass 7 data. So there are 3 4.5s. So 8th, 9th, and 10th data are 4.5. So can you see that? 9th and 10th are 4.5.
Question, Professor. How would we know it's in order?
They are in order, 2.5, 3, 4,
But
5.
you know, how sometimes when they're put out on a list, they're not.
Oh, if they're not in order, then you have to rearrange them in order.
Okay.
You to find median, you had to have them in order. Okay. But usually, when they make a frequency table, the data will be in order. They don't make a frequency table in a random order.
That's what I was wondering. Thank you.
Yeah. So it'll be already in order. And so all you have to do is go from the beginning and locate the middle. First, you had to calculate the location of the middle. And we calculated that as 9 and 10, 9th and 10th. And so let me begin again. When I pass 2.5, I pass 3 data. When I pass all of the 2.5s, 3 data will be passed. When I pass all of the 3s, I pass 7 data, the sum of these, 7 data. So 8th, 9th, and 10th are 4.5, which means 9th and 10th are 4.5, and average of those two will be 4.5. So therefore, median is 4.5. That's our conclusion. Any question on that? All right. Moving on to population data and sample data. You need to understand the difference between them. Population data means actual data of all of the data that we need to use. So let me give you a simple example. If I need to use population data to find the mean income in New York City, then I have to have the income of everyone in New York City. That's what we mean by population data, the actual data of all of the people. But that's very difficult, right? You get the information, income information for some part of the New York City, Manhattan, and when you're finished and when you move on to Bronx, the Manhattan data is already changed. So it's not possible to have that actual data perfectly right. So we normally do sample data. Sample data means you just randomly select sample information from, reasonably random. That means I cannot just take all of the data from Manhattan. I have to go to the other areas and count and take some data from everywhere. So takes a good sample of data from every section, every part of the city, and use that to find the average. That'll be your mean income. So sample data is an easy way of getting approximate answer because accurate answer is almost most of the time impossible. So when you find the mean using sample data, that's called sample mean, and the notation for that is X bar. X bar represents sample mean. When you use the population data, actual data, sometimes the population data is available. Like, for example, if I'm finding mean grade in my class, I have all of the data. I don't need to take sample. So I can use all of the data to find the mean. So if you're using population data, which means all of the data, all of the actual data, then the mean is called population mean. And the symbol is this, mu. You must use that symbol and you must understand the meaning of it. It is mean, just a different symbol. So when you're writing it on the board, you write like that. It's basically a U with a tail in the front. So that is how you write it. Okay, so that's called mu, and that it's a Greek symbol. This is one of the alphabets in Greek. So the reason for the Greek symbols is, like I explained before, most of the probability and statistics theory were developed by Greek mathematicians. And so they introduced these symbols, and now we are stuck with them. So population mean will be written as mu, sample mean is written as X bar. Okay, so let's, we already know how to kind of find the mean. We learned already. Basically, you need to add them up and divide by count. But if you're using sample data, then you have to call it sample mean. If you're using population data, you call it population mean. And if it is arranged in frequency table, then we already learned how to find the mean of this data. You make another column FIXI, add them up and divide by the total count, all that. So we already know how to find them. And also if the data is grouped into intervals like this, we know how to approximate the mean. You use the middle points. All right, with all that, let's go on to understand the variance and standard deviation. So what we have done so far is different measures of middle point. The mean, median, and mode are three different ways to measure the middle. What we are going to learn next is dispersion. Just knowing the middle is not good enough to analyze the data. See, in statistics, you use these different measures to analyze the data and come up with useful conclusions. And so these different measures are useful for the analysis. And so we need to understand all these different measures here. Now, we are not doing analysis in this course. If you are going to move on to statistics course, you'll be doing analysis and you'll be using these ideas there. So in addition to knowing where the center is, we need to know how dispersed the data is. So that's what we're going to measure next, the measure of the dispersion. To explain what dispersion means, I have some data here. So let's look at these data. 2, 18, 24, 32, 46, 64. These are 6 numbers. And if you look at those 6 numbers and these 6 numbers, you may not be able to immediately see the dispersion is different. They both have the same mean. You can easily find the mean, add them up and divide by the count. The mean is 31 here and the mean is 31 here also. So middle point seems to be same for both. At least one middle, the mean. There are 3 middles, we are not comparing the other ones. At least one middle seems to be the same, but the dispersion is different. You can see that this data is more dispersed. It goes from 2 to 18 and then 24 and goes all the way to 64. It's in a wide range. And this is in a shorter range. That's what it means to say dispersed. The first data is dispersed more than the second. Right? It goes from 22 to 41 in a shorter range. The other one is 2 to 64, a larger range. So that's dispersed more. So it's not the range. Range is only one measure of how dispersed the data is. We only learned what the range is. Largest data minus smallest data. So largest data minus smallest data, in this case is 62. And here is 41 minus 22. So that's smaller, much smaller. So the range is only one measure of the dispersion, but there are other measures of the dispersion that we're going to understand here. And these are, those measures of the dispersion are called variance and standard deviation. So I'm going to show you how to calculate the variance. You need to find the mean first. You need to find the middle, mean. And then if it is population mean that you have, we call that mu. Then what you need to write is difference between the first data and the mean. And you need to square it. Difference between second data and the mean, square it. And go all the way to the last data minus mean, square it. And then divide it by the total count of the data. N represents total count of the data. So you need to add up the squares of the differences between mean and each data. Mean and each data. So that'll tell you how far away every number is from mean, right? So you're squaring them and adding them up, because the reason for squaring is because some of them can be negative. If you add negative and positive numbers, you can end up with a 0. So that's not a good measure. So that's why you have to square them and add them up and divide by the n. So this is what we call the population variance. The notation for that is sigma squared. Now this sigma, let me put it on the board. You write sigma this way. You begin here, and so it's like an O with the tail in the top. So this sigma represents, it's called sigma. And there's another one called sigma, right? What does that look like?
Isn't that like a E, a backwards E?
Yes, exactly. This represents summation, and that's also sigma. Why do we call both of them sigma? Well, they're Greek letters, like I said. This is the lowercase sigma. This is the uppercase sigma. All right. Unfortunately, we had to deal with that. That's how those are the symbols they used, and we had to learn them. The uppercase sigma represents summation. So if I write sigma fi xi, that means multiply all of the frequencies by all of the data and add them up. So this means add up. This represents the population variance. Sigma squared represents population variance. I'll explain in a minute why squared. So sigma squared is the notation for population variance, and the population standard deviation is simply the square root of that. The reason for square root is because you added up the squares of the numbers, so you had to bring it down to size by taking square root of everything. And so if you take the square root, that gives you population standard deviation. So standard deviation is simply square root of the variance. If I take the square root of population variance, I get population standard deviation. If I use square root of sample variance, I get sample standard deviation. The notation for population variance is sigma squared. Notation for population standard deviation is sigma, because it represents square root of the other one. So that's why we call this sigma and the other one sigma squared. Sample variance is called S squared. We use S squared as the symbol. It's the same thing as population variance, except that you're using sample mean. Sample mean is represented by X bar. So X1, each data minus sample mean, square it, and the next data minus sample mean, square it, and all the way to and cover all of them. Sum of those squares will be divided by n minus 1 in the case of sample variance. So that's one thing that's going to be a little bit of a problem for you to remember, that if it is population variance, you divide by the entire count. If it is sample variance, you divide by one less. There's a weird reason for that. The mathematicians who designed these formulas for the variances thought that in the sample case, one of these can be 0. In other words, one of the data can match the mean. So therefore, you have a 0 in there. So since if you have a 0, then the actual number of things you are adding up here are one less than the count of the data. That's the reason. So one of them can be 0. So therefore, if you divide by n, that's not accurate. So divide by one less. That's the decision they made, and so we're going to have to live with that decision. So this only in the sample case, you need to divide by one less. In the population case, you need to divide by entire count. So how do we know whether sample data is given or population data is given? Usually you can tell from the context, or the problem will make it clear. It'll tell you whether it's sample data or population data. So for example, if I say, these are the grades of students in a class, find the mean. and standard deviation. Now you know it is population data because it says these are the grades. It's not a sample grade. So you have to apply the population formula to do that. Population formula means find the mean. If you find the mean of that data, that'll be population mean, and then use that population mean and apply the formula that is given in the first box, dividing by the full count. If it is sample data, you have to apply the second formula, which is essentially the same idea, except that you're dividing by one less. And then if they ask for the standard deviation, then all you have to do is take square root. All right, so let's do this for simple problem first. These are the data I was discussing earlier to compare the dispersion. This data is dispersed more than this data. So let's check out their variances. And then you'll know. The variance is a measure of how dispersed the data is. All right, so I'm calculating, excuse me. I'm calculating the variance of the first data, this. I already know the mean is 31. So here is my calculation of the population variance of the first data. These are population data. 2 minus 31 squared. 2 is the first data. 2 minus 31. 31 is the mean, population mean. So 2 minus 31 squared minus plus 18 minus 31 squared, 24 minus 31 squared. I add them all up and then divide by this 6 because this is population data. So the count 6 can be used. If it is sample data, you have to divide by 5, not 6. And you had to use your calculator to do that calculation, and it came up 395.67. For the second data, if I apply the same thing, 22 minus 31, 26 minus 31 squared, 30 minus 31 squared, and so on, I'm getting 37.33. See how different they are? The first data was dispersed more, and it has much larger value for the variance. The second data has smaller, 37.33. Okay, so that's how you find them. Now the exercise 10 says, find the population variance and population standard deviation. Now, can we do it? How do we do it? We do it exactly the way it's done here. Just add up the squares of difference between each data and the mean. First, you have to find the mean, and then do that. So if you do that manually, the way I showed you up here, that's fine. But it'll be a lot easier if you do them in an organized way in a table. So the table method of calculation is the old-fashioned way, but it is effective way. So if I want to group them, if I group them, it's going to be much easier. So I'm going to group them. 50 is there one time, frequency is 1. And the 70 is there 3 times. So 70 is there 3 times. 80 next. 2. 90 has 2. Okay. Now, the first step is to find mean, right? To find mean, I'm going to multiply FIXIs. So I get 50 and 210, 160, 180. And then I add up these FIXIs. That'll be the same as the total of all the data, sum of all the data. So these are grades of students, and adding these up is same as adding these up. So 160, I'm trying to add in my head, 260, 340, 550, 600. Okay, 600 And the sum of the frequencies is 7, 8. So therefore, I can find the mean now as 600 over 8, which is 7.5.
75.
Yeah.
It's
If you
not
get,
a decimal.
I'm sorry.
Not a decimal. It's just 75.
Yes, 75. 75. So here it's coming up a whole number. If it is coming up fractional, then problem will tell you how much of rounding you can do. So you round the number only if the problem tells you to round it. Otherwise, you have to carry all the digits, up to 4 digits, not more than 4. The next thing is, so now I have the mean, 75. So I need to calculate the difference between xi's, xi minus mean, right? I'm going to write the word mean. I cannot type that symbol. So each one minus mean. That's what I need here. Okay, let's move this over. Make it larger. All right. So each data minus mean. Maybe I should just copy and work it on the board. All right, for some reason it gives you all these colors, but it doesn't matter. So xi minus mean, I need to do that. Um, mean is 75, so 50 minus 75 is minus 15. So this is the way you do the work in an organized way.
Negative 25.
Right, okay. This table is not working out for me.
Wouldn't it be squared, Professor?
We will square it in the next column.
Oh, okay.
All right, so minus 25, and then where am I? 50 minus 75. Next one is 70 minus 75, right? This is the 70 minus 75. That's 5 minus 5. Doesn't matter whether you write the negative or not. You're going to square them. 80 minus 75 is 5. 90 minus 75, 15. And now we're going to square. So xi minus mean square. That's what you're going to do next. And that'll be 25 squared is 525, 5 squared 25, 5 squared 25, 15 squared 225. And you add them, and that will be 550, 575, 600, 800. Let me check one more time.
Negative 25 squared is 625.
Oh, you're right, 625, right. Thank you. 625, 650, 675, 700, 900. Okay, 900. Okay, so I'm sorry. No, I made a mistake here. Anybody recognize the mistake? All right. No, I shouldn't be adding these. I need to calculate one more column, because xi minus mi squared, this 625 is there 50 times, not 50, I mean 1 time, and this number is there 3 times, isn't it? The frequencies. Remember, the 70 is there 3 times, means this is going to be there 3 times in the actual list. Okay, so similarly, 80 is in the original list, the data 80 is repeated 2 times, means this number is repeated 2 times. So basically what I need to do is I need to do fi times mi xi minus squared. So each number here we found should be multiplied by the frequency. You understand what I mean, right? So you go back and look at the original data. The 70 is there 3 times. So 70 minus 75, which is 5, is going to occur 3 times. 3 of those are there. We wrote that, we wrote each data here and then wrote the frequencies here. So that means the 70 is there 3 times, means 70 minus 75 is going to occur 3 times. So after squaring, I need to multiply by the frequency because each of that square is there 3 times, or for whatever the frequency is. So 625 is there only once, so only one 625. The 25 here is there 3 times, so 3 times 25, 75. This 25 is there how many times? 2 times, so 50. 225 here is there 2 times, so 450. Only now we add them up. This is the correct sum of all of those. 625 plus 75, 700, 750, 800 plus 400, 1200. So 1200 is the correct sum. And that 1200, this is population data. So therefore, we are finding population variance. Okay, so population variance, so for sigma squared is 1200 divided by the total count of the data. Total count of data is 3 plus 1, 4 plus 2, 6 plus 2, 8, 8. So divide it. $150. So sigma squared variance. Often variance is abbreviated as VAR, VAR, equal to 150. So standard deviation equal to square root of 150. That's all it is. Use your calculator to find square root of that. That's your answer for that. So if you do it in this organized way, it is much easier, and also you can track your work again and figure out anything that went wrong. But you have to calculate these columns, xi minus mean, and then square them in another column, then multiply by frequency in another column, because each strata is repeated that many times, and add them up. Any questions so far? All right. So that finishes variance and standard deviation for data that is not organized or organized into frequency table. If they give you data already organized into frequency table, you do the exact same thing by extending the table. So the data grouped into class intervals, I'll discuss that. It'll only take a few minutes, but I don't want to take your time. We are out of time. So we will discuss that in the next class. And then in the next class, we'll be doing the next handout, the next worksheet, which is normal distribution. So if you want to have that ready, you can put in that. So this worksheet was there. One student said it was not there, but I went back and checked. The worksheet was there under the right title. So you must have made a mistake.
I think it's numbered wrong, Professor. Because I think the one
Yeah.
before this it said 14. The one we did before this was 14. And then this one says 16.
Okay, the reason is
Yeah.
there
But
is
you put 14 and 15 together.
okay, that's what happened. The reason why that happened is because we skipped one topic, and so that's why I got the numbers mixed up. Sorry about that. But if you go to the 16, worksheet 16, that is there correctly. And the worksheet 17 is also there with the right number.
So worksheet 16 isn't this worksheet 16?
This is
It's a different one?
Yeah, this is a 16. This is correct.
Okay, so the next one will be just a 17.
17, yes.
Okay, thank you.
You're welcome. All right, so worksheet 17 is there. You may want to have it printed out. But this is all you have for the homework today. All right.
Thank you, Professor.
You're welcome. Have a nice day and
You
enjoy.
too.
And we have our last class will be 17th, May 17th. I'm still debating whether we should have the exam on that day or not, third exam. So whatever decision I make, I will let you know. Most likely, third exam will be on that day, not before that, the last day, 17th.
On the 17th?
Yeah.
Oh, okay.
Okay. It'll be easier. If I push it to a class before, it may be difficult. So,
Are you going to give us a practice test?
yes. I don't know whether I have it posted or not. If not, I will post it. I will post a practice test.
Okay.
Okay, thank you.
And also, when are we gonna have the final?
The final is going to be the following week, May 17th is a Monday. The following Monday, which is going to be 24th, I believe. Okay, that's the test day.
So not the 20th?
24th. May 17th is the last day of classes. That's a Monday. The following Monday is going to be the final exam.
If I'm just a little bit like maybe about 10 minutes late, is that okay? Because I have another final that same day on the 24th.
Okay.
And because I have a class right before this one, so sometimes it conflicts with I have to take a test.
Yeah, it's 10 minutes late will be fine. I can give you that 10 minutes at the end. Yeah, no problem.
Okay. All right, thank you.
Mhm.
Wait, so I'm sorry. The exam's gonna be the 24th or the 17th?
No, the exam 3 will be on the 17th. Final exam will be the 24th.
Okay, thank you.
Mhm.
How long would the final exam be, or are you not sure yet?
It is going to be double the size of the regular exam, and you'll be officially given 2.5 hours, but I'll give you extra time, another half an hour or 45 minutes.
Okay, thank you. Have a good day, Professor.
You too. Bye-bye.